Hey guys, we're going to be continuing here with Chapter 7, Section 6. We're going to be talking about exponential functions. And we're not going to do a lot with them. This is more of just an introduction to what these look like. So don't get too nervous about this looking weird or ugly or anything like that. Make sure you take good notes and you should be perfectly fine. Alright, so the definition is an exponential function is a function of the form y equals a times bx, where a is not 0 and b is greater than 0, and b cannot be equal 1, x is a real number. Alright, so a couple of examples that I want you to copy into your notes as to what they look like. Here I have y equals 2 to the x, which is a little line that kind of swoops up, and it goes off in this direction forever. It would go off in this direction forever. The negative version is the same thing, just flipped over the x-axis. Here would be 1/2, or a fraction raised to that. Notice how it kind of flops this over the y-axis. Here is negative 1/2 x. So this is just the shape of what an exponential function looks like, and that's really what I want you to be familiar with now. All right, here's a little bit of advice for the cold. We're getting close to spring here, so we still have some cold days. So if you ever are feeling cold, here's my advice. If you ever get cold, just stand in a corner for a bit. They're usually around 90 degrees. Oh, that's a dad joke. Okay, so identifying linear and exponential functions says, does the table or rule represent a linear exponential function? What we're looking for is something that's consistent throughout the way the x changes and the y changes. So here we can see that the x's are increasing by 1. Down here, okay, so this would be minus 2, then minus 6, and then minus 18. Okay, so that's not going to work. I want to know, is there a way I can get from this to this consistently every time? Well, I noticed that this times 3 is that, times 3 is that, times 3 is that. All right, so for this one, I'm repeatedly multiplying. Repeated multiplication is what an exponent is. Here's what I mean. If I have 2 cubed, that means repeated multiplication of 2, or 2 times 2 times 2. So anytime I have repeated multiplication, that's when you need to think exponential. All right, so here, this is an exponential function. Where there's a ratio of 3. So you just need to be able to identify it as exponential at this point. Okay, so exponential because it's times 3 every time. This one right here, this next one is linear, and this is really simple. My explanation is because there's no exponent. And there actually is an exponent. It's an assumed exponent of 1, but this is a good enough definition right here. All right, so that's linear because there is no exponent. So let's keep going here. All right, so evaluating an exponential function. Evaluating is easy. Remember, that's when you just substitute in. So it says, suppose 30 flower beetles are left undisturbed in a warehouse bin. The beetle population doubles each week. The function f of x equals 30 times 2x gives the population after x weeks. How many beetles will there be after 56 days? So here's the part that we need to be careful with. This function is for weeks, but I have days. So 56 days is equivalent to how many weeks? We'll divide that by 7. So 56 days is 8 weeks, so I'm going to solve my function for 8. So 30 times 2 to the 8th. So f of 8 equals 30 times, let's see, 2 to the 8th is 256. And 256 is equal to, or times 30, is equal to 7,680. So that's a lot of beetles. All right, so again, with this, just make sure that you're being careful because they'll slip these things in to throw you off where the function's given for weeks but the number that you're given is in days. So you just want to make sure that your units are matching. All right, so graphing an exponential function. It says, what is the graph of this? Pretty simple here. You're just going to make a table. All right, so I'm going to make an XY chart. You could make a more elaborate table where you show plugging in. In fact, that's the example the book gives, but for me, this is good enough. I like to use the same points every time. So I'm going to do -2, -1, 0, 1, and 2. And I'm just going to substitute these values into this. All right, and you could do this on a calculator. That's perfectly fine. So when I put -2 in here, I end up getting 3/4. When I put -1 in there, I get 1 1/2, or I'm going to say 3/2. When I put 0 in there, I get 3. When I put 1 in, I get 6. And when I put 2 in, I get 12. All right, so this is just a matter of taking -2 and substituting it in. So I do 3 times 2 to the -2, which again, remember, that moves that down here. So that's 3 divided by 2 squared, which is 3 divided by 4. That's where the 3/4 comes from. All right, so I'm going to do that. It says plot the points then. So here I have -2 and 3/4. All right, so that's going to go, let me change my color here so that you can actually see it. So 3/4 is roughly right here. Then I have -1 and 3.5, which is the same as 1.5. Then I have 0 and 3, so there we go. And we kind of start seeing a curve here. I have 1 and then 6, so this is going to go up a lot more. And then 2 and then 12, which is way off of my thing here. So I have 6, 7, 8, 9, 10, 11. We'll just guesstimate and say it's right in that area. So you can kind of see the shape here that's taking place, that in order to connect that, now I'm doing my best to go through the points. You should do a better job because you're not writing on a computer. But you can kind of see the curve of the function that's going like this. All right, so to do these, just make a table. Here's one for you to try. The answer will be up in 3, 2, 1. All right, so here's what I got, something that looks like this. Again, notice how it's curving upward. And let's keep going. All right, so these are graphing calculator problems. What I want you to do with this, solving one variable equations using graphing calculator, says what is the solution of this? If you have a graphing calculator with you at home, go ahead and attempt to do this. Otherwise, this is going to be something that we're going to have to practice in class. But I want you to go ahead and already have this copied out in your notes. So go ahead and pause and copy all of this out in your notes. And then when we get to these problems in class, if you don't know what to do, this is when you need to ask for help. And I'll come by or have a classmate come and help you use a graphing calculator to do this. But you could use a graphing calculator to find the solution of this by doing intersections. Okay, so make sure you have this copied down. And there's that problem. There's another one. We don't need to do that because you probably don't have a graphing calculator at home. All right, so that is it for these notes. Hopefully you took good ones, and I will see you in class.